All right, ready to dive deep. Today's all about a device that's shrouded in, well, mystery and history. It's practically begging to be explored. The Enigma machine.
Ah.
You know, that thing that kind of looks like a typewriter had a baby with a robot.
Yeah.
To help us crack this case, so to speak, I've got an expert with us.
Hello.
Who can shed some light on how this thing actually worked. Ready to unravel some secrets.
Absolutely. The Enigma machine, that's a really fascinating example of how something seemingly simple at its core.
Yeah.
It's an electromechanical device for secure communication could become such a formidable puzzle.
It definitely looks complicated. I mean, we're talking about Nazi Germany using this thing to protect military secrets, so it had to be some serious business.
Oh, it was. And that's what makes the story of how they broke the Enigma code so incredible. It was a true testament to human ingenuity and persistence.
I'm hooked already. So let's unpack this. What exactly was the Enigma machine?
So essentially, it was a sophisticated encryption device. You can almost imagine like those secret decoder rings we had as kids.
Right.
But instead of simple substitutions, the Enigma used these spinning rotors to scramble letters.
Okay.
Creating an incredibly complex code. And the Germans used it extensively during World War II to protect their communications.
Adding another layer of mystery to an already captivating story. So no magic involved, just clever engineering.
Precisely. Think of it like a combination lock.
Okay.
But way more complex. So with every key press, these rotors would spin.
Yeah.
And that would change the wiring and create a different cipher. So the same letter typed twice could encrypt as two completely different letters.
Wait, so you're telling me that pressing the letter A twice wouldn't necessarily give you the same encrypted letter twice?
Exactly.
Talk about a nightmare to decipher.
Exactly. The Enigma made it nearly impossible to crack without knowing the exact settings of those rotors.
Yeah.
And the number of possible combinations was astronomical.
Mind-boggling, but it was all based on electricity, right?
Right.
So how did pressing a key on one end result in a jumbled letter on the other?
So imagine electricity bouncing through a maze.
Okay.
And getting scrambled at each turn.
Okay.
That's basically how the Enigma worked. Each key press sent an electrical signal through this intricate pathway of rotors, and each one scrambled the signal further.
So it wasn't just about the rotors spinning, it was the specific way that they were wired internally that caused all the scrambling.
You got it. And they could even swap out these rotors, making the code even more complex. It was like a constantly shifting puzzle.
They really thought of everything to make this thing unbreakable, huh? But as you mentioned earlier, it was broken. How did they pull that off? Was there some fatal flaw in the Enigma's design?
There were some weaknesses, yes.
Okay.
But perhaps even more important was the human element.
Okay.
Surprisingly, German operating procedures and simple human error played a role in Enigma's downfall.
Interesting.
And it all started with a group of brilliant Polish mathematicians.
Wait, Polish mathematicians before the war even started? Talk about being ahead of the curve.
Absolutely. These mathematicians, they were instrumental.
Okay.
They discovered flaws in the way the Germans used the Enigma, and that revealed crucial information about the rotor settings.
So even the best laid plans can be foiled by a little human error. It's like leaving a clue in plain sight.
Exactly. And those clues, combined with the Poles' ingenious techniques, allowed them to start reading German messages as early as 1933.
Wow, that's incredible. They cracked Enigma years before the war even began. But I'm guessing the Germans caught on eventually, right?
You're right. The Germans were constantly trying to improve Enigma's security, which made decryption more difficult. But as the war loomed, the Poles knew they had to share what they knew.
Yeah.
Just weeks before the German invasion, they shared their knowledge and techniques with the British and the French.
Talk about a clutch move. International cooperation at its finest.
Yeah.
But what happened next? Were the British and French able to pick up where the Poles left off?
So that information proved to be the foundation for the Allied code-breaking efforts.
Right.
At a place you might have heard of, Bletchley Park.
Okay, yeah.
England.
Bletchley Park. That's where all the magic happened, right?
Yes.
The stuff of legends.
Bletchley Park became the central hub for Enigma decryption throughout the war.
Wow.
But cracking those ever-evolving codes, well, that would require even more ingenuity.
Yeah.
Resources.
Yeah.
And a little bit of luck.
All right, we've got the stage set. The Poles cracked the Enigma's early versions, shared their secrets, and Bletchley Park is gearing up to take on the challenge. I'm already on edge of my seat. This is where things get really interesting, right?
Absolutely. The story of Bletchley Park and how they tackled the increasingly complex Enigma is one you won't want to miss.
Welcome back to our deep dive into the Enigma machine.
Yes.
Last time we left off with the Polish mathematicians cracking Enigma's early versions and sharing their knowledge with the Allies right before the war. That intel was crucial for setting the stage at Bletchley Park.
Bletchley Park, a name synonymous with code breaking and wartime espionage. So paint us a picture. What was it like? Was it a bunch of people huddled in a dark room with just pencils and paper?
Not quite. Picture a bustling hub of activity.
Okay.
more like a small village than a dark room. Bletchley Park housed thousands of people
working tirelessly to decipher enemy communications.
Thousands. Wow. So who were these masterminds cracking the Enigma?
It was a diverse group.
Okay.
Mathematicians, linguists, chess champions, even crossword enthusiasts.
Wow.
All brought together by their unique skills
and
a common goal to break the Enigma and help the Allies win the war.
That's amazing. It really sounds like they recruited anyone who could think outside the box.
Right.
But they weren't just using their brains, were they? I've heard about these super secret machines they built to help with the code breaking.
You're thinking of the bombs.
Okay.
These incredible electromechanical devices that were essentially high-speed Enigma simulators.
Oh, wow.
They could rapidly test thousands of possible rotor settings.
Okay.
Looking for clues that could reveal the Enigma's daily key.
Hold on, so they built machines to crack a machine? It's like a mechanical duel.
It really was. No. And it was a race against time, too.
Yeah.
With the Germans constantly changing Enigma's settings.
Right.
To try to stay one step ahead.
So how did the bombs actually help crack the code? Did they just like spit out the answers?
Not quite. They sped up the process.
Okay.
But the code breakers still needed strategies to narrow down the possibilities. One technique involved looking for cribs, which were guessed or known pieces of plaintext within the encrypted message.
So like if they knew a message was likely to contain like Heil Hitler or some other common phrase, they could use that as a starting point.
Exactly. Think of cribs like puzzle pieces.
Okay.
If you know one piece of the puzzle, it helps you figure out the rest. If they guessed a crib correctly, the bombs could test if that crib when encrypted with different rotor settings matched the intercepted message.
Clever. But didn't that rely on a lot of desk work? How did they know what cribs to use?
Well, that's where understanding the German military mindset came in.
Okay.
Bletchley Park wasn't just full of mathematicians and engineers.
Right.
They had linguists, historians, even people who knew German military procedures and lingo.
So they could make educated guesses based on how the Germans usually communicated?
Precisely. They would consider things like weather reports, common commands, even the personality of the German operator.
Interesting.
Sending the message. It was like a giant game of chess.
Yeah.
Trying to anticipate the enemy's next move.
It sounds like the code breakers had to be part detective, part linguist, and part mind reader.
Yeah.
But I'm curious, were there any major setbacks at Bletchley Park? Did they ever hit a wall where the codes just seemed unbreakable?
There were definitely challenges. Remember, the Germans were constantly trying to improve Enigma's security.
Right.
They introduced new rotors, changed procedures, even created more complex machines like the 4-rotor Enigma used by the Navy.
So it was an ongoing arms race with the code breakers having to constantly adapt their techniques and tools.
Exactly. And they worked under immense pressure.
Yeah.
Knowing that loads depended on their success.
Yeah.
It was a truly remarkable feat
of
ingenuity, dedication, and perseverance.
Speaking of remarkable feats, what was the actual impact of breaking Enigma? How did it affect the war?
So the intelligence derived from Enigma decrypts, codenamed Ultra,
Okay, Ultra, okay.
had a profound impact. It allowed the Allies to anticipate German movements, disrupt their plans, and make more informed strategic decisions.
Can you give us some specific examples of how Ultra helped to win the war?
Absolutely. Ultra was crucial in the Battle of the Atlantic.
Okay.
The Allies used it to track and intercept German U-boats, which were wreaking havoc on Allied shipping.
So basically, Ultra helped the Allies win the Battle of the Atlantic?
Yes.
That's huge. What else?
Ultra also played a crucial role in the North African campaign.
Okay.
The D-Day landings.
Right.
And countless other operations throughout the war.
Wow.
Many historians believe that breaking Enigma shortened the wars significantly.
Yeah.
And saved countless lives.
Wow. The impact is undeniable. But did the Germans ever suspect that their prized Enigma had been compromised?
There's some debate about that.
Okay.
While they suspected Enigma might be vulnerable at times, they never fully grasped the extent to which the Allies had penetrated their communications.
So they kept using Enigma, thinking it was secure, while the Allies were reading their mail, so to speak.
Yes, the Germans placed so much faith in Enigma's complexity that they overlooked the human element, the errors, and the Allies' ingenuity.
It's a valuable lesson for us today, even in our digital world.
Right.
No matter how advanced our tech gets, we can't underestimate the human factor.
Exactly. The Enigma story is a powerful reminder that technology alone doesn't guarantee security. It's the combination of human brilliance, collaboration, and constant vigilance that makes the real difference.
We've uncovered so much in this deep dive, from the mechanics of the machine to the brilliant minds that cracked it.
Absolutely.
But the story doesn't end with the war, does it? What's Enigma's lasting legacy?
That's a great question, and one we'll explore in the final part of our deep dive.
Okay.
We'll delve into the lessons learned from Enigma, its impact on modern cryptography, and its enduring influence on our world today.
Welcome back to our Enigma deep dive.
Yeah.
We've journeyed through the intricate workings of the machine, met the brilliant minds who cracked those codes, and we saw how it shaped the course of World War II. Now let's consider the legacy of Enigma.
Okay.
What enduring lessons did it leave us, and how is it still influencing our world today?
Well, the Enigma story, it has so many layers. And it's still incredibly relevant, even in our digital age. You know, it highlights the importance of cryptography, that constant battle between code makers and code breakers. But beyond that, it reminds us that technology is just one piece of the puzzle. Human ingenuity, collaboration, persistence, these are just as vital.
You're right. We saw how human error was a factor in Enigma's downfall, and how those brilliant code breakers use their collective brain power to crack those seemingly unbreakable codes. It shows that even the most advanced tech is vulnerable to the human element.
Absolutely. The Enigma story also teaches us the importance of staying vigilant and adapting. So the Germans kept tweaking the Enigma throughout the war, trying to stay one step ahead. It's a cat and mouse game that continues to this day, you know, with cybersecurity and data protection.
So Enigma's legacy isn't just a history lesson. It's about the evolution of cryptography and how those lessons from the past can help us secure our digital future.
Exactly. Many of the principles used to break Enigma are still relevant today. Things like frequency analysis, recognizing patterns, and finding those subtle weaknesses. They all have roots in the Enigma era.
It's amazing how those early code-breaking triumphs laid the groundwork for modern cryptography. But did Enigma itself directly inspire any of today's techniques?
Well, today's encryption is way more complex than Enigma's rotor system. Its story has definitely shaped the field. It emphasized the importance of keeping keys secret, having super strong encryption algorithms, and understanding how how your adversary thinks.
So it's less about the specific mechanics of Enigma and more about those overarching ideas and mindsets.
Right. Enigma was also a catalyst for developing more sophisticated cryptographic machines and techniques.
Okay.
You know, the lessons learned spurred the creation of even more secure methods.
Yeah.
Ultimately paving the way for the digital encryption we rely on today.
Wow. So in some ways we owe our secure digital lives to Enigma. That's mind-blowing.
You could say that. Enigma forced innovation in cryptography, pushing people to create stronger, more resilient ways to protect information. It was a pivotal moment in understanding the importance of encryption and its role in keeping communication safe.
Okay, so Enigma's impact goes way beyond the battlefield. It's woven into the very fabric of our digital world.
Yes.
But let's not forget the human side of this story.
Right.
You know, those code breakers at Bletchley Park, those unsung heroes.
Yeah.
Their stories are truly inspiring.
Absolutely. Their dedication and perseverance, were crucial in changing the course of the war.
Yeah.
Their work was top secret for so long, but now their achievements are finally being recognized. They're an inspiration to us all.
It's proof that even in the darkest times, human brilliance can shine through, and that the work of a dedicated few can truly change the world.
I couldn't agree more. And as technology keeps advancing,
right, and
cybersecurity threats become even more complex,
the
Enigma story reminds us that human intelligence, collaboration, and a relentless pursuit of knowledge are more important than ever.
This deep dive into the world of Enigma has been an amazing journey.
It has.
We've learned about the machine, the remarkable people who cracked its codes, and the lasting lessons it offers.
Before we wrap up, I'd like to leave our listener with something to ponder.
Okay.
Imagine a world where Enigma was never broken.
Wow. Yeah.
How would history have unfolded?
Right.
What would our world look like today?
Yeah.
It's a powerful thought.
Yeah.
And it really emphasizes the impact of Enigma and the legacy of those who dared to unlock its secrets.
It really makes you think. Thank you for joining us on this incredible adventure into the world of the Enigma machine. We hope you've enjoyed the deep dive. And maybe it's sparked a curiosity to learn even more about this fascinating piece of history.
Welcome to another deep dive. This time, we're tackling a concept that's both intensely personal and universal: the soul.
You got it. And it really is something that every culture and belief system seems to have grappled with in some way. This idea of a non-material essence, that's what we're going to be looking at.
And it was you who asked to delve into this.
Right.
From all sorts of different angles.
Yeah, I'm really interested in how differently people view this.
And we're using the Wikipedia article on soul as our main source here.
Perfect starting point.
So let's kick things off with the basics. What exactly is the soul? How do we even define it?
Well, think of it as this non-material essence that's part of a living being. A lot of people believe it holds our identity, our personality, even our memories.
Like the core of who we are.
Exactly. And it's often seen as the part of us that goes on, after our physical bodies are gone, that survives death.
So it's not just our physical body. There's something maybe a little more ethereal.
Right.
But here's a question. Is this soul something that's unique to humans?
Not necessarily. Some belief systems, like animism, actually say that everything has a soul. Plants, animals, even inanimate objects. Imagine a world where even a rock has a soul.
Whoa, that's pretty mind-blowing. It really shows how differently people have thought about the soul throughout history.
It really does. Even the word itself, soul, it's got a whole history to it. It comes from Old English, has roots in all these Germanic languages where it often meant something like life or an animate being.
So the word itself is pointing to something lively, vital.
Yeah.
But we know the concept of the soul goes back way further than that. Yeah. Like ancient Egypt, for example, with all their elaborate beliefs about the afterlife.
You're absolutely right. Ancient Egyptians were way ahead of their time when it came to soul concepts. They had all these intricate ideas. And a great example is the Kutumua stele. It's from the 8th century BCE, a funeral monument for a royal official.
Right.
And the inscription on it, it actually asks people to celebrate his life for my soul that is in this stele.
Wait, so they thought his soul was actually in the stone monument?
That's the idea. It shows us that even back then, people were thinking about the soul as separate from the body, capable of existing on its own.
That's fascinating. Okay, so we've got this basic idea of the soul, right? This non-material essence, maybe present in everything and maybe surviving death. But how do different religions actually interpret this?
Right, because there are a lot of different takes on it.
I know you've got a ton of info on this.
I do, and you wanted to see variety. Well, let's start with the Abrahamic religions, Judaism, Christianity, and Islam. Even within those, there's some really interesting differences.
Yeah, let's unpack that. Let's start with Judaism and Christianity. What are the key differences in how they see the soul?
Okay, well, both believe in one God and that the soul is super important, but their emphasis is different. Judaism focuses on how your actions during your life here on earth affect your soul. So a good life, lived according to God's commandments, leads to a good soul.
So it's about living right, aligning yourself with a divine moral code, as it were. What about Christianity?
Some Christian groups, while they value good living too, put more emphasis on what happens after death. The idea of judgment and what happens to your soul in the afterlife. It's less about the soul's journey here and more about its destination in the next world.
Ah, so in that view, your actions determine whether your soul gets rewarded or punished, right?
Right.
It makes me think about that debate within Christianity. When does a soul actually enter the body?
Yeah, that's a huge question, especially with things like, the ethics of abortion. If a soul is there from the moment of conception, then the whole moral landscape changes.
Absolutely. And speaking of interpretations, the Wikipedia article mentions this really interesting idea by Thomas Aquinas, tota in toto corpore. What does that even mean?
It's Latin, means the whole in the whole body. Aquinas, he was a major Christian thinker. He said the soul, even though it's immaterial, isn't located in one specific part of the body. It's present in every single part of you, fully.
So it's not like the soul is just hanging out in your heart or your brain. It's more like it permeates your entire being.
Yeah, that's the idea.
It makes you think about the connection between the physical and the spiritual, doesn't it? Like, maybe it's not such a clean separation.
It really does blur the lines.
So even within one religion, like Christianity, you've got such a variety of ideas about the soul.
Hmm.
Okay, let's shift gears to Islam. How do they understand the soul?
Well, they actually have two words for it, ruth and nafs.
Two words, okay.
Ruth is like the breath of life, the divine spark that comes from God. It's what gives us life, animates us.
So it's what makes us alive, essentially.
You could say that. And then nafs, that's more about our individual self, our personality, our desires, our ego.
Okay, so two sides to the same coin, in a way.
Yeah, and in Islamic philosophy, they see ruth, that divine breath, as the driving force behind nafs, our personal self.
Oh, I see. So there's this interplay between the divine and the personal within each of us. That's really interesting.
It is.
All right, so we've talked about the Abrahamic religions, but what about Eastern religions like Hinduism and Buddhism? They have some totally different views, right?
Oh, yeah, they do. Like in Hinduism, the soul or Atman, that's considered your true essence. But here's the really wild part. Atman is seen as identical to Brahman, which is the ultimate reality, the cosmic consciousness behind everything.
Hold on. So the soul isn't just a part of you. It's part of the very essence of the universe.
Exactly. And that's a whole other level of interconnectedness.
That's intense. Okay, what about Jiva? The Wikipedia article mentioned that too, in relation to Hinduism.
Right. Jiva is like the individual expression of Atman in a living being. Think of Atman as the universal soul, and Jiva as the specific way it shows up in each person.
Okay, so each being carries a piece of that universal soul. That's a pretty profound concept. What about Buddhism? Do they have anything similar?
Actually, Buddhism's core teachings kind of challenge the whole idea of a permanent, separate soul.
Really? No soul at all?
Well, they have this idea of anatman, which means no self.
Okay, so does that mean we don't exist?
No, not exactly. It's more that what we think of as our self, our ego, personality is an illusion. Buddhism suggests it's not some unchanging soul underneath it all. It's all these fleeting experiences, emotions,
So
perceptions.
it's not that there's nothing there, it's just that it's constantly in flux, changing, impermanent.
Exactly. It's a radical departure from a lot of the other ideas we've been talking about.
Wow. We went from rocks having souls to no soul at all. Seems like there's a whole spectrum of beliefs here.
And we haven't even touched on shamanism yet, which is a whole other fascinating take on this.
Well, don't leave me hanging. Tell me about this shamanic view of the soul.
Okay, so shamanism is practiced all over the world, and they have this really cool idea called soul dualism. It means you have more than one soul.
Wait, multiple souls? How does that work?
Lots of shamanic traditions believe in a body soul, which is linked to our physical stuff, and a free soul, which can detach and travel around during sleep or trance states.
So while you're dreaming, your free soul is out there exploring the spirit world.
Yeah, something like that.
That's pretty wild.
Yeah.
But kind of cool, too. Are there any cultures today that actually believe in this soul dualism?
Oh, yeah, for sure. The Tagbanwa people in the Philippines, they believe in 6 souls. One's the free soul, and the other 5 have different jobs, like dealing with emotions, dreams, even our connection to ancestors.
6 souls? That's a lot to juggle. But it really does show how diverse these beliefs about the soul can be.
Absolutely. And we've only scratched the surface here. We haven't even gotten into the philosophical side of things yet. Like, Socrates and Plato had a whole lot to say about the nature of the soul.
Well, it sounds like we're just getting started. This deep dive is already shaping up to be quite the journey.
And when it comes to the soul, philosophy really offers some diverse views on it. You ready to dive into what some of the big thinkers had to say?
Oh, absolutely. Philosophy always adds another layer to things, doesn't it?
Yeah.
Like peeling back an onion, but instead of making you cry, it gives you mind-blowing insights.
I love that. Okay, well, let's start with those classic Greek philosophers, Socrates and Plato. They saw the soul as the real essence of a person, the driving force behind why we do what we do.
So our actions are like a reflection of our soul, they'd say. Makes sense on some level. But didn't Plato go even further with that idea?
He did. You wanted to see different perspectives.
Yeah,
Right?
you know.
Well, Plato's idea of the tripartite soul, that really embodies it. He said the soul's got 3 parts to it:
3 parts.
logos, thymos, and eros.
Okay, I gotta admit, those Greek terms always throw me off a bit. What do they actually mean in plain English?
Right, so logos represents reason and intellect, that part of us that thinks things through.
Okay, the logical side.
Exactly. Thymos is about our emotions and that gut feeling that pushes us to act, that spiritedness.
Got it. And eros.
That's all about our desires, the things we crave and want.
So food, relationships, all that.
Exactly. Plato thought these 3 parts are constantly at play with us, kind of like an internal struggle. Ideally, logos, the reason part, is in charge, keeping the others balanced.
So if your logos is running the show, you're living a reasonable, balanced life. But what happens when eros takes over?
Well, that's where things can go off the rails, according to Plato. Too much eros. And you end up chasing pleasure all the time, and ultimately that leads to unhappiness.
Yeah, I can see how that would happen. It's funny, Plato's tripartite soul kind of reminds me of how we feel pulled in different directions sometimes, by our thoughts, emotions, and desires, like an internal tug-of-war going on.
It totally is. Plato actually compared it to a well-functioning society.
Really?
Just like in society where you need different roles and people working together in harmony, the parts of the soul gotta cooperate so a person can truly thrive.
I like that analogy. It makes me think that maybe self-awareness is key here, right? Being aware of those inner forces can help keep them balanced. So that's Plato's view, pretty complex. But his student, Aristotle, he had a different take on it, right?
Yeah. He did. Aristotle, he also thought the soul was super important, but his view was a bit more grounded, you could say. He didn't think the soul was separate from the body, but more like the realization of a living being's full potential.
So for Aristotle, the soul isn't this airy, intangible thing floating around. It's more like the force that makes a being what it's supposed to be.
You got it. And he even proposed this hierarchy of souls.
A hierarchy?
Yeah. Plants have the simplest kind, focusing on basic survival stuff like growing and reproducing. He called that the nutritive soul, or bios.
Okay.
Then animals, they have a more complex soul that allows for things like sensation and movement. That's the sensitive soul, or zoo.
And humans are at the top, I'm guessing.
You know it. We've got the rational soul, or susha, with all those higher thinking abilities.
Interesting. Putting humans at the top does feel a bit, I don't know, human-centered, right?
Yeah, you could say that. But for Aristotle, reason was what really set humans apart, so it makes sense in his framework. But hold on, there's a bit of a contradiction. with Aristotle. He's all about the soul and body being connected, right?
Yeah.
But he also entertained this idea that the intellect, that part of the human soul, might be immortal.
Wait, so part of the soul could live on after death, even though the soul is tied to the body?
That's the debate among scholars. Some say, yeah, Aristotle believed that. Others think he saw the soul as totally linked to the body and therefore mortal. It's one of those ongoing philosophical mysteries.
Very intriguing. Okay, so we've covered some ancient views on the soul. But how do things look in the modern world, especially with all the advancements in science?
Yeah, modern thinking brings in a whole new set of tools and ways of looking at things, especially from neuroscience and physics. Remember, you wanted to explore the soul from different angles.
Definitely.
Well, these fields offer some really interesting insights.
So how does science, with all its focus on the material world, approach something like the soul, which seems so intangible?
Well, take neuroscience, for example. It tries to explain our mental processes, like our thoughts, feelings, memories, as results of brain activity.
So no mystical soul stuff floating around, just neurons firing and synapses connecting.
That's the dominant view, yeah. But even within neuroscience, there are some things that challenge this purely materialist view.
Really? What kind of things?
Like, have you ever heard of near-death experiences?
Oh, yeah. Where people have these really vivid conscious experiences even when their brain activity has basically stopped.
Exactly. And those are hard to explain away as just, random brain chemistry.
Right. It makes you wonder if consciousness isn't totally dependent on the physical brain, maybe there's something more to us.
It definitely raises questions. And some researchers think these near-death experiences point to exactly that there's more to consciousness than we currently understand.
Wow. So neuroscience is still grappling with this. What about physics? How does that weigh in on the soul question?
Well, some physicists, like Sean Carroll, argue that based on what we know about physics, specifically quantum field theory, a traditional soul is very unlikely.
Okay, what's their reasoning?
They basically say if there were these soul particles or some kind of soul energy interacting with our bodies, we would have already detected it in our experiments.
So from their perspective, the soul doesn't fit into our current understanding of how the universe works. Sounds like science is kind of challenging those traditional soul concepts.
It's true that looking through a scientific lens can lead to different conclusions, but, science is always changing, always finding new things.
That's a good point. There could be new discoveries that change everything. All right, so we've talked about neuroscience and physics. What about the folks who try to study the soul directly, like parapsychologists? What do they say?
Well, parapsychology is all about investigating things that seem to go against conventional scientific explanations, like out-of-body experiences, telepathy, even life after death.
So they're looking for proof, for evidence, to back up those more mystical or spiritual ideas. Have they found anything concrete?
That's where the debate gets heated. Some researchers say they have found evidence for the soul, but a lot of mainstream science is skeptical of their methods.
Okay, are there any famous examples of this kind of research?
Sure. There's the famous 21 grams experiment from way back in the early 1900s.
I think I've heard of that. Didn't some doctor try to actually weigh the soul as it left the body at the moment of death?
That's the one. This Dr. Duncan McDougall, he weighed patients before and after death, and he claimed he found a slight decrease in weight right at the moment of death. He said that's the soul leaving.
And he even said the soul weighed 21 grams, right?
Yep.
That's both fascinating and a little creepy, but was it good science?
Most scientists say no. His experiment had some major flaws, and other researchers haven't been able to replicate his results. It's more likely the weight loss he saw was from other things happening in the body. So the scientific community doesn't really accept his findings as proof of a soul.
So the mystery of the soul continues. It's really interesting how we've gone from these ancient religious beliefs to modern science, and the soul is still this big question mark. Where do we even go from here?
That's the beauty of it, right? It's a concept that makes us think, makes us question. It's been centuries of people trying to figure it out, and we still don't have all the answers.
It seems like it's less about finding the one definitive answer and more about appreciating all the different ways humans have tried to understand this really complex idea.
Yeah, each perspective adds a little piece to the puzzle, even if we don't have the complete picture yet.
Well said. I think it's time to wrap things up. What final thoughts do you have for our listeners as we end this deep dive into the soul? It's really amazing to think about all the different ideas about the soul we've covered. We've gone from ancient Egypt to modern physics, from the idea that everything has a soul to the idea that there's no self at all.
And yet, through it all, the soul still captures our imagination. Even with all our scientific progress and philosophical thought, it's still this big mystery that we're trying to understand. I think it speaks to how important this concept is to us.
It makes me wonder if this fascination with the soul, this need to believe there's more to us than just our physical bodies, if that's just part of being human.
I think you're onto something there. The concept of the soul, it can offer comfort, give meaning to our lives, make us feel like we have a purpose, especially when we think about our own mortality. It helps us grapple with those big questions. Why are we here? What happens after we die? Are we all part of something bigger?
It's true. This whole deep dive has really made me think about my own, soul map, you know?
Yep.
Yeah, all the beliefs I've picked up along the way, the things of the soul that really resonate with me, and the things I still question. It's like we each create our own understanding based on what we've experienced and learned.
I love that, a soul map. And those maps, they can change as we learn and grow and come across new ideas. It's not about finding one right answer. It's about staying curious and open to different perspectives.
So after this deep dive into the soul, with all its twists and turns, what's the one thing you really want our listener to take away from it all? If they could walk away with just one key insight, what would it be?
That's a good question. I think the most important thing to remember is that the soul, whatever it may be, is something that invites us to keep exploring, keep reflecting. It's a journey of discovery, both for ourselves and for humanity as a whole. And it's that very act of searching, questioning, trying to understand, that's what enriches our lives and deepens our connection to this profound mystery.
Well said. That's a great point to end on. So to our listener, as you continue your own exploration of the soul, we'll leave you with one final thought-provoking question. With so many diverse views out there, is there one universally correct understanding of the soul? Or is it a concept that changes and evolves as we gain more knowledge, as our beliefs shift, and as we gather new experiences? Keep diving deep and keep those questions coming.
Ready for a deep dive, folks? Today, we're tackling Mercury. We've got tons of cool info from the Mercury Wikipedia page. Should be a fun one.
Yeah, Mercury's pretty awesome. It's one of those planets that often gets overlooked, but it's got a ton of personality once you get to know it.
Totally. Most people know the basics, right? Smallest planet, closest to the sun, rocky surface. Kind of like Mars in a way, but there's so much more to it than that.
Oh yeah, for sure.
Like, for example, did you know that a day on Mercury is actually twice as long as its year?
Yeah. It's crazy, right?
It's mind-boggling. How is that even possible?
Well, to really understand that, we probably need to start way back, like way before telescopes and all that. How did ancient civilizations even view Mercury?
Yeah, let's rewind the clock. What did people think Mercury was back then, before we knew what we know now?
So get this, they actually thought it was two different planets, one that appeared in the morning and a totally different one that showed up in the evening.
Whoa, really?
Yeah. It wasn't until the Greeks came along, around like 350 BC, that they figured out it was actually just one planet.
That makes sense, though. I mean, trying to track Mercury from Earth with just your eyes, that must have been super tricky.
Oh yeah, definitely.
But hey, at least they gave it some pretty fitting names. Stillbon for Twinkle, and Hermes because it zipped across the sky so fast.
Right. And the Romans kept that whole messenger god theme going, calling it Mercury after their own speedy deity. Made sense because Mercury appeared to move faster than any other planet in the sky.
Zipping and zooming all over the place. And hey, speaking of cool names, its astronomical symbol is pretty neat too. It's like a stylized version of Hermes' staff, the caduceus, but with a cross added later on. Kind of blends the ancient with the modern, don't you think?
Yeah, I love that. It's like a visual reminder of how much our knowledge of astronomy has evolved over time.
Totally. Okay, so we've talked about its speedy reputation. But what about its physical characteristics? We know it's the smallest planet, even smaller than Jupiter's moon Ganymede and Saturn's Titan. But here's the thing, it's super dense, right?
Oh yeah. It's incredibly dense. Second highest density in the whole solar system. Only Earth beats it.
Wow. So what's going on beneath the surface of this tiny, heavy planet? What's it made of?
Think of it like a layered cake.
Okay, I'm intrigued. A cosmic cake.
So the outer layer is a solid silicate crust and mantle. Pretty similar to Earth's, actually. But then you get to the good stuff, the filling, if you will, a massive iron core. And it's not just any core either.
Oh.
Tell me more. Scientists think it's layered too. You've got a solid outer core, then a liquid layer, and then another solid inner core. It's like a planet within a planet.
Whoa, a core within a core. That's wild. But hold on, why is Mercury's core so huge compared to its overall size? It seems a little out of proportion, don't you think?
You're right, it is a bit of a mystery. Scientists have come up with a few theories to try and explain it. One idea is a giant impact early in the solar system's history. Basically, picture baby Mercury getting slammed by a huge object.
Ouch.
Yeah, cosmic hit and run. And this impact was so powerful that it basically stripped away a big chunk of Mercury's outer layers, leaving the core as the dominant feature.
So like a cosmic demolition derby, with Mercury taking a major hit.
Exactly. Another hypothesis focuses on the intense heat of the early sun. Imagine young Mercury just baking under the protosun. The temperatures were so extreme that they basically vaporized a lot of the surface rock.
So it was like a cosmic sauna?
Kind of. And as those lighter elements vaporized, they were blown away by solar winds, leaving behind a denser, iron-rich planet.
So it was cooked down to its core, like a pressure cooker, but on a planetary scale.
Precisely. Then there's the solar nebula theory. This one suggests that as Mercury was forming, the solar nebula, that's the swirling cloud of gas and dust, created a drag on the material that was coming together to build the planet. And this drag might have pulled away lighter elements, leaving more of the heavier iron behind.
So it was like the sun's gravity acted as a giant vacuum cleaner, selectively sucking away the lighter stuff.
Yeah, something like that.
3 very different scenarios, but they all lead to the same outcome. A planet with a seriously oversized iron heart. So, how do scientists figure out which theory is the most likely? It seems like a tough puzzle to solve.
Well, they're looking closely at the clues on Mercury's surface. Missions like Messenger and Bepi-Colombo are analyzing the amounts of certain elements, like potassium and sulfur. These elements are volatile, meaning they vaporize easily at high temperatures. If Mercury had experienced a huge impact or lots of vaporization, you'd expect those elements to be pretty scarce.
Right, because they would have been blown away.
Exactly. But Messenger actually found higher levels of potassium and sulfur than expected, which lends more support to that solar nebula theory.
So it's like a cosmic detective story, using these chemical clues to try and piece together Mercury's past.
Absolutely. And with Bepi-Colombo still out there gathering data, we're hoping to get even more pieces to this puzzle.
This is already so fascinating, and we've only scratched the surface, literally. We still have to explore what the actual landscape of Mercury looks like, and I have a feeling it's going to be just as mind-blowing as its interior.
Oh, you're in for a treat. Mercury's surface is a testament to billions of years of cosmic bombardment, volcanic activity, and all sorts of geological processes. Get ready for craters, plains, cliffs, the works.
I can't wait. Let's blast off to the surface of Mercury. Okay, we've journeyed to the heart of Mercury. Now it's time to explore its surface. From what I gather, it's a pretty wild place.
Oh, you have no idea.
Being so close to the sun, I can only imagine what it's like.
Well, the first thing you'd notice if you were standing on Mercury is craters, and lots of them.
Oh, I bet. Like our moon.
Yeah, kind of like the moon, but even more so. Craters everywhere, big ones, small ones, old ones, newer ones. It's like a cosmic shooting range out there.
Wow, that's intense. So just a constant, never-ending landscape of craters, nothing else.
Well, not exactly. There are also these vast, smooth plains, and scientists think these were formed by ancient volcanic eruptions.
Wait, volcanoes on Mercury? I thought it was way too small for volcanic activity.
That's what we thought for a long time, too. But Messenger really changed our understanding of Mercury's geology. It found evidence of volcanic activity much later in Mercury's history than anyone expected.
That's incredible. So this little planet had a fiery past, huh? What else would we see if we were walking around on Mercury?
Get ready for some dramatic scenery. You'd encounter these towering cliffs called roops, some of them hundreds of kilometers long and several kilometers high. They cut across the landscape like giant scars.
Wow, roops. Those sound epic. How did those form?
They're kind of like Mercury stretch marks. You see, as the planet cooled over billions of years, it also contracted. And remember that massive iron core we talked about?
Yeah, Mercury's giant heart.
Right. Well, as the core cooled and shrunk, it basically pulled the surface inward, creating these incredible roops.
So Mercury's literally shrinking. That's kind of mind-boggling.
It's happening very slowly over eons, but it has had a profound impact on the landscape. And speaking of impact, have you heard of Caloris Planitia?
Oh yeah, the giant impact basin.
Exactly. It's the largest impact basin on Mercury. This colossal scar is over 1,500 kilometers in diameter. Imagine the state of Texas, but even bigger.
That's massive. What could possibly create an impact crater that enormous?
It must have been a cataclysmic event. I mean, the impact that formed Caloris was so powerful that it not only carved out this gigantic basin, but it also triggered volcanic eruptions and created a ring of mountains around it. The basin itself is filled with this unique, smooth plain, which scientists think is solidified lava or maybe even impact melt. Talk about a force of nature.
It's incredible to think about the interconnectedness of everything. I mean, an impact like that not only changes the surface, but also affects the interior of the planet.
Yeah.
But hold on, what about the weird terrain? I heard that's a pretty strange feature.
The weird terrain is this jumbled, chaotic region on the exact opposite side of Mercury from Caloris. It's like the antipode, the polar opposite point.
Okay, so on the other side of the planet from this giant impact basin.
Yep. And scientists think the weird terrain is the result of the shock waves from the Caloris impact. Imagine those shock waves traveling through the planet's interior and converging at the antipode. It would have been like a seismic earthquake that deformed the landscape in this really bizarre way.
So the Caloris impact actually shaped the landscape on the other side of the planet. That's just wild.
It's a testament to the power of these cosmic events. But let's not forget, if you were actually standing on Mercury, you'd experience something else pretty intense, the temperature swings.
Right, we touched on that earlier. Just how extreme are we talking?
Well, during the day, you'd be baking under a scorching sun, with temperatures soaring to around 430 degrees Celsius. That's hot enough to melt lead. But as night falls, the temperature plummets to a frigid -180 degrees Celsius. Talk about needing a versatile wardrobe.
That's almost a 600 degrees Celsius difference. It boggles the mind to think anything could survive those extremes.
It's definitely not a place for the faint of heart. But there's a surprising twist. Believe it or not, there's actually water ice on Mercury.
Hold on, ice? On Mercury? With those temperatures, you're pulling my leg.
I know, it sounds crazy, right? But here's the thing. There are permanently shadowed craters at Mercury's poles.
Okay, I'm listening.
The temperatures in these craters never rise above -170 degrees Celsius. So water ice, likely delivered by comet impacts or maybe released from the interior, can actually collect and survive in these cold traps.
So even on a planet as seemingly hostile as Mercury, you find the potential for one of life's essential ingredients. That's amazing.
Yeah. It definitely challenges our assumptions about where we might find the building blocks of life. It makes you wonder what else is out there waiting to be discovered.
Absolutely. Okay, so we've got craters, cliffs, crazy temperatures, and even ice. What about an atmosphere? Does Mercury have one?
It has what we call an exosphere, which is sort of like an atmosphere, but much, much thinner.
Right, kind of like a wispy, barely there layer of gas. So what's floating around in Mercury's exosphere?
It's a mix of stuff, actually. You've got hydrogen, helium, oxygen, sodium, potassium, even some water vapor. It comes from a variety of sources like the solar wind, tiny meteorite impacts that kick up dust and gas, and even some outgassing from the planet's interior.
So it's constantly losing and gaining material. It's a very dynamic system, isn't it?
It is.
Damn
and
right.
Despite being so thin, this exosphere plays a role in the fascinating interactions between Mercury and its magnetic field.
Oh yeah, the magnetic field. You mentioned it's unusual for a slow-rotating planet like Mercury to have a magnetic field. Can you remind me how that works?
Sure. The prevailing theory is that it's generated by what we call a dynamo effect. Basically, the circulation of molten iron in Mercury's massive core, probably helped along by tidal forces from its elliptical orbit, creates electric currents that generate the magnetic field. It's similar to how Earth's magnetic field is generated.
So even though it's spinning slowly, there's a lot going on deep inside Mercury that creates this magnetic shield.
Right, but there's a catch. It's not a perfect shield. Messenger discovered these things called magnetic tornadoes. They're basically twisted bundles of magnetic fields that connect Mercury's magnetosphere to interplanetary space.
Magnetic tornadoes. That sounds intense.
They are, and they act like funnels, allowing the solar wind to reach the surface in localized areas. It's like Mercury's magnetic field is leaks.
So not as strong as Earth's magnetic field, but still playing a crucial role.
Exactly. Okay, ready for another dose of Mercury's weirdness? Let's talk about its orbit and rotation. Remember how we mentioned that a day on Mercury is longer than its year?
Oh, I definitely remember that. That's the fact that really blew my mind. So how does that even work? What's going on with Mercury's orbit and rotation? Right, lay it on me. What's so weird about Mercury's orbit?
Well, it's the most eccentric orbit of all the planets in our solar system.
Eccentric.
It's not a nice circular path around the sun. It's more like an oval, a really stretched out one.
So Mercury's basically on this cosmic roller coaster, swinging in close to the sun and then way back out.
Exactly. And that creates some pretty crazy effects. Like we've already talked about those wild temperature swings, but that varying distance from the sun also generates some seriously powerful tidal forces.
Oh, I bet. Much stronger than what we experience from the moon here on Earth.
Way stronger. And you know what? Those tidal forces play a big part in Mercury's really strange rotation.
Okay, here we go. This is where things get mind-boggling.
Right. Mercury's rotation is locked in what we call a 3.2 spin-orbit resonance with the sun.
A 3.2 what now? You got to break that down for me.
Basically, it means that for every 3 times Mercury rotates on its axis, it completes 2 orbits around the sun. It's like a cosmic dance, but with the steps and the music totally out of sync.
Okay, I think I'm starting to get it. So how does that affect the length of a day on Mercury?
So a sidereal day, which is the time it takes for Mercury to spin once on its axis, is about 59 Earth days. But because of that weird resonance, a solar day, that's the time between sunrises, is a whopping 176 Earth days.
Wait, hold on. A day that's longer than its year?
You got it. Mercury zips around the sun pretty quickly, so its year is only 88 Earth days long. So yeah, a day on Mercury is twice as long as its year.
That's just bonkers. Imagine having to wait like over 5 months between birthdays.
I know, right? It's crazy to think about, and it gets even weirder. Imagine standing on Mercury at just the right spot. You'd actually see the sunrise, then appear to stop, reverse direction, set for a bit, and then rise again.
What? Seriously?
Yeah, all within the same Mercurian day. It's because of the way Mercury's rotation and orbital speed are constantly changing as it moves closer to and farther away from the sun.
It's like the sun is playing tricks in the Mercurian sky.
Yeah, exactly. You wouldn't see that anywhere else in the solar system. And then there's this whole thing about Mercury's perihelion. That's the point in its orbit where it's closest to the sun.
I've heard about that. Didn't it have something to do with Einstein's theory of relativity?
You got it. Back in the 1800s, astronomers noticed this strange shift in Mercury's perihelion. They couldn't quite explain it with Newtonian physics. It was this tiny little discrepancy, but it was enough to drive them nuts.
So how did they figure it out?
Well, along came Einstein with his theory of general relativity. And his theory explained that the sun's gravity actually warps space-time, which causes Mercury's orbit to precess, or like shift a little bit more than they originally predicted.
So this tiny planet actually played a role in confirming one of the most groundbreaking theories in physics.
Pretty cool, huh? And speaking of cool, our understanding of Mercury wouldn't be what it is today without some pretty awesome space missions.
Right. We have to talk about the spacecraft that dared to venture so close to the sun and gave us a glimpse of this incredible world. So what missions have explored Mercury?
Well, the first one was Mariner 10 back in the 1970s. Before that, we only have blurry images from telescopes. But Mariner 10 flew by Mercury 3 times and sent back the first detailed pictures of its surface. It showed us the craters, the plains, those crazy cliffs we talked about, even gave us clues about its magnetic field.
It must have been a real game changer for scientists studying Mercury.
Oh, absolutely. It opened up a whole new world of understanding. But then came Messenger, which actually orbited Mercury for 4 years, from 2011 to 2015.
Wow, 4 years in orbit. That's impressive.
It was a truly groundbreaking mission. Messenger mapped almost the entire surface in high resolution, confirmed the presence of water ice in those shadowy polar craters, analyzed the exosphere, and gave us tons of data about Mercury's magnetic field and interior structure.
Talk about rock star among planetary probes. What about current missions? Anything going on right now?
Yes. Bepi-Colombo, a joint mission between the European Space Agency and the Japan Aerospace Exploration Agency, is currently en route to Mercury.
So there's more to come.
Oh, yeah. Bepi-Colombo is carrying 2 probes that are packed with even more advanced instruments. It's going to be studying Mercury's magnetic field, surface composition, and interior structure in even greater detail. We're expecting some really exciting discoveries from this mission.
I can't wait to see what they find. So as we wrap up our deep dive into this incredible little planet, what's the big takeaway? What have we learned about Mercury?
I think Mercury has really taught us that even the smallest, seemingly insignificant objects in our solar system can be incredibly complex and full of surprises. It's a reminder that there's so much more out there to explore and discover.
Absolutely. Who would have thought that this little scorching world held clues to the formation of our solar system, the evolution of planets, and even Einstein's theory of relativity. It's a reminder to never underestimate the power of exploration and the thrill of discovery.
Well said. There's always more to learn, more to explore, and more to wonder about.
Thanks for joining us on this amazing journey to Mercury. Keep looking up, folks, and never stop exploring.